Hello, this is Dr. Hein, and welcome to the Math Bunker. Today we're asked to make a t-table with at least 2 points and then sketch the graph of each line. Here I have an equation in slope-intercept form. Y equals x plus 5. We know it's in slope-intercept form because y is all by itself on the equal sign. And we're asked to draw a t-table and sketch a line. So a t-table literally looks like the letter T. And my coordinates will be x and y. X will be my independent variable. It can be any number I want it to be. Y is called my independent variable because y depends on whatever I decide x to be after I put it through the formula. Okay? And so let's say that x, I'm going to input 0 for x. And question would be, what is y? So I take the equation y equals x plus 5. And I'm going to go ahead and turn the x into parentheses. Y equals x as a parentheses plus 5. And I'm going to input 0 for x. And then I'm going to do the math. 0 plus 5 is 5, therefore y equals 5. And so if my input, my independent variable is 0, when x is 0, my output, y, would be 5. And then I'll simply plot it starting from my origin. The origin is when the y-axis meets the x-axis, right in the middle at 0, 0. And I'll start with x. Sometimes I call this my run. I'll go left and right. X is 0, so I won't go left and right, but y is 5. I'll go up 5 units. 1, 2, 3, 4, 5. And then I'll plot my first point. Now I need 2 points to draw a line, and I have to use a number other than 0 because I've already used 0. I'm going to use 1. I'll go back to my formula, y equals x plus 5. I'm going to write it over here this time. Y equals, now remember my x can be a parentheses, added to 5. My input was a 1, which is x. So I input 1. My output, which will be y, would be the math, 1 plus 5. 1 plus 5 is 6, so therefore y will equal 6. That means when x is 1, y is 6. And I go back to my origin. Now x is 1, this is the x-axis. That means it's a positive 1, so I go over 1 unit. Now y is 6, I go up 6 units. 1, 2, 3, 4, 5, 6. And I plot up my second point. Okay. Now using a straight edge, in this case I'll use my protractor, I'll connect the 2 points that I just located on the graph. And that line will look like this. And the 2 points 0, 5, which is called my y-intercept. Another thing, if it's in slope-intercept form, y equals x plus 5, y is by itself, that last number will be the y-intercept. When x is at 0, y will be at 5. Another point on the line, I decided x is 1, my input, my output is 6. So it runs 1 unit on the x-axis, and it rises 6 units. I have 2 arrowheads to represent infinity. Okay? So let's try this again. I get an equation that says y equals 6x plus 5. I want to start with drawing a t-table. And I have the x value and the y value. If you can picture like a soda machine, your input is what you press on the outside of the machine. And so if you select X, then it goes through its formula and it tells you if X was, soda 1. It'll go through the mechanics, and the output, what comes out of the bottom, would match with your X. In other words, the Y would correspond with the X. And so some of the easiest numbers to use is 0 and 1, just so that it can fit on the graph. And if that doesn't work, you can use -1. You can use any number that you want because there will be an X value that matches with a Y value. And one of the easiest numbers to use is 0 because it makes the math easy. Because this is 6 times a number plus 5 will get me Y. So in other words, 6 times 0 plus 5, my output would be Y. 6 times 0 vanishes because 0 times any number, it's gone. And that leaves me with a 5. Okay. Another thing we can do, if we use 0, we can use a cover-up method and just cover up X. So when X is 0, we'll just cover up the X. And that's anything touching the X. And I'm left with Y equals 5. And so I start at the origin. X is 0. It doesn't go left or right because X is 0. But Y is 5. I have to go up 5 units. So I rise 1, 2, 3, 4, 5. And I'll plot a point. Okay. So now let's say that X, I'm going to select, I'll go ahead and select 1, even though it may not fit on my graph, that's fine. Say I select 1, so I'll write the equation at the bottom so I can have some room. I'll write Y equals 6, and instead of running an X, I'm going to go ahead and write a parentheses and put plus 5. Now I decided that X is going to be 1, so I'll plug in the number 1, and then I'll do the math. 6 times 1 is 6. And then when I add 5, Y will equal 11. This is a pretty big number for this small graph. My graph only goes to 6 numbers. So we'll find out what to do when this happens. So when X is 1, I go over 1 unit, Y is 11. I can go up 1, 2, 3, 4, 5, 6 units. I'm going to just go ahead and guess, just for fun. So 7, 8, 9, 10, 11. I'll make this a guess. I'm just going to make a target so I can play a little battleship game. So I need another number that will fit. So 0 fits on my graph. 1, 11 is a number on the line because the line goes into infinity. It's there as long as it goes to the formula. It just may not fit on the graph. Let's see what happens if we select -1. Let's see if that fits. So I'm going to put -1. If X is -1, I'm going to rewrite the formula. Y equals 6X. Again, I'm going to make parentheses. And then I'm going to add 5. Now my input is -1. I'm going to input -1. And I'm going to do the math. 6 times -1, this is a positive times a negative, is -6. And then when I add 5, a -6 and a positive 5, Y will equal -1. And so I'll write that down for Y. My output is also -1. And so I'll go to my origin. X is -1. I will go back 1 unit to -1 on my x-axis. Y, the run or the rise, the Y is -1. I'll go down 1 unit and plot it. Now I have 2 points. And this was just a guess. I wasn't sure where 111 is, but I'm going to play a battleship game. I just want to see if my guess was right. And the numbers are correct. 111 is a point on the line. My graph, it just may not fit. And so I play this game. I'll match up my points and visualize myself in the battleship, and I'll fire and see if my guess was right. And so I'll fire a torpedo, boom. I'll draw arrowheads, and it was a guess again. It happened to be right. So if the graph was longer, it would fit. And there are countless numbers of x's and y's on any line. That is how to sketch a line using a t-table with just whole numbers. So let's try one when the coefficient of x, when I say the coefficient, a coefficient is a number in front of x is a variable. So let's try one when the coefficient is a fraction. Okay, I have an equation y equals 1/2 x plus 5, and I'm going to sketch a line by constructing a t-table, and I'm going to practice doing one that has a fraction. Okay, and let's say we have a t-table. X and y. And one of the easy numbers to use is 0, because anytime you multiply a number times 0, you're going to get 0. So my input is a 0. So I'm going to say 0. I'm just going to do this first part. 0, which is x, times 1/2. So I'll do this down here. Y equals 1/2x is parentheses. I'll plug in a 0, and then I'll add 5. Well, anytime you multiply 0 times a number, it is 0 plus 5, and therefore y will equal 5. And so when I input 0 in the formula y equals 1/2 x plus 5, my output will be 5. And this is also called my y-intercept, because this is where it's going to hit the y-axis. I can still use the cover-up method. If x is 0, I can just cover up x and its coefficient. Its coefficient would be 1/2. I cover it up. That leaves me only with 5. Y equals 5. And so I plot it on the y-axis. So x is 0 right here. It doesn't go left or right, but y is 5. I go up 5 units and plot a point. Okay. Now, when you get 1/2, it get a little tricky, because it can, anytime you multiply 1/2 times the number, it's always half that number. Okay, so let's say that I think that 1 might be an easy number. It is for the other numbers, especially the whole numbers, because every time you multiply 1 times a number, it's always going to be that number. So let's do that. Let's take 1/2. Let's say my x is going to be 1. I multiply 1/2 times 1, and then I add it to 5. Once again, anytime you multiply a half times any number, it's always half that number. So 1/2 times 1 is 1.5. And if I was to add 5, my output would be 5.5. Or I can call it 5.5. And so when my input is 1, my output is 5.5. And so you really could plot it, but it's not perfect unless you get in one of the corners. The 0.5 will be sort of a guess, and it's easy to guess halfway. But let's start at the origin. X is 1. I go over 1 unit. Y is 5.5. I go up 1, 2, 3.5, or 5.5, and try to figure out where is the half mark. Now I'm going to guess again. I'm just going to make a dash here, and that's about halfway. That would work. But what if I want to be exact? I want to be on one of the corners, you know. Well, the number I wanted to use, focus on this. If it's 1.5, or any fraction and the top number is 1, you can turn it into the number 1 by multiplying it by the denominator, whatever the denominator is. In this case, the denominator is 2. So I'll work it over here. So I'll say y equals 1/2, and I'm going to multiply it times the denominator, which is 2. And then I'm going to add 5. Okay. And now notice this. 1/2 times 2 is always half the number when you multiply 1/2. So I'll make it 1. And when I add 5, I make it 6. So if I input a 2, let's use this t-table, and I input a 2, when you input 2, your output will be 6. And there's another point. Now I have 3 points, 1, 2, 3. And this one wasn't really perfect because I think this is halfway between the 5 and the 6. So I'm going to start the origin, and the x is 2. I'm going to go over 2 units. 1, 2. But y is 6. I'm going to go up 6 units. 1, 2, 3, 4, 5, 6, and draw a point. And notice my guess, my halfway mark, it's very, very close. And then with a ruler or straight edge, we're going to draw a line through those 2 points. And this line represents y equals 1/2 x plus 5. Okay, here's another example. Y equals 3x. We're not used to, or rather, we're used to seeing a number here, and when there's not one, you know, the y-intercept, we assume that that's 0, and actually it is 0, because nothing, 0 is the only number that represents nothing or something that doesn't exist. But let's just work that problem. With a simple t-table, we'll draw a t-table. X value, y value. Now we learn that some of the easier numbers to pick for our x value is 0 is an easy number to use, 1. If 1 throws us off our grid, we can try -1. If we have a fraction where 1 is the top number, we can just use the denominator like 2. Or if 1 over 4 was the fraction, we would use 4. And that would actually turn it into the number 1. Okay, so we're simply going to use 0. And 0 times any number, this is 3 times a number, will equal y. So this means y equals 3 times, I decided to be 0. And so 3 times 0 is 0. And so that means when x is 0, y is 0 in this case. And that's the origin. The origin is when the x-axis meets the y-axis, and when x is 0 in this formula, y is also 0. So I need a second point. I'm going to input the number 1. And just simply do the math. 3 times 1. Well, 3 times 1 is 3, so y will equal 3. Therefore, when x is 1, y is 3. I'll plot my next point. I'll start at the origin. X goes over 1 unit on the x-axis, and then it rises 3 units. So over 1, up 3. Again, I line my points up and put 2 arrowheads at the end of my points to represent infinity. And this line represents y equals 3x. Another example, what if you get one that says y equals 3? Notice the x portion, or the slope portion, is missing. And so we can still solve this with a t-table. I'll make a simple t-table of x and y. And I'll plug in 0 for x. Now, I have to substitute 0 for x, and there's no x to substitute. Well, therefore I'm done. But what is y? Well, look what it says. Y equals 3, so y must equal 3. That's simple enough. So if I was to plot it, x is 0. I don't go left or right, but y is 3. But I need another number, so I'm going to pick 1. X is 1. Well, again, there's no x to substitute, so let me look at my equation. What does y equal? It says y equals 3. Y must equal 3. And then I plot it. X is 1. I start at the origin. I go over 1 unit. 3, I go up 3 units. 1, 2, 3. And when I connect my points, I'll have a perfect horizontal line, and where it hits the y-axis, it will hit the y-axis at 3. And if I can understand this concept, that if this was a target, if that was the y target, and I fire an arrow, it will hit it only at 3. It'll be a perfect horizontal line, and later when we talk about slope, or M stands for slope, it has a slope of 0. It's perfectly level. And there you have it. These are a few examples, only a few examples, how you can use the t-table and sketch a line on a graph. Again, this is Dr. Hein, and thank you for joining me in the Math Bunker.